so the beginning of what I need to talk about right now is kind of like side stuff. M&Ms in general used to publicize a distribution for their different colors. And they quit doing that. So we're kind of going to have to decide which one we want to use. What I'm about to talk about is pretty much not what statistics at all right now. But this is interesting and it goes with it. Where'd it go? M&M's actually changes their colors over the years. And they say they changed it based off of what people want. So this right here is over the years so I think it started in 1941. The different colors, so they've always had brown, they've always had yellow, they always had green. I was looking this up this morning. I did not realize this. There was, for I think 10 years, they didn't have red because there was something about a red dye that, I can't remember what they said it was. There's some issue with red dye and people were really, really against it because it had something in it. And their red did not have that in it, but because of public conception, they were afraid to get the bad rep for it, so they took it out. So they took it out for 10 years and then ended up putting it back in after everything kind of cleared. They brought in orange when they removed red, and they left orange. I had no idea there was ever a violet. Apparently they had a light tan that was there for a while, and they replaced that with blue, probably before y'all were born. And so these are the distributions now, but obviously the proportions over time have changed if the colors themselves have changed. But also the different types of M&Ms have different color distributions. So like peanut M&Ms are different than milk chocolate M&Ms. But because they don't publicize it anymore, and this was interesting, I am not a Stranger Things kind of person, but they were talking about the third season of Stranger Things started was set in 1985, which they did not have red M&Ms at the time. And they said in the opening scene, somebody was eating M&Ms and they had red M&Ms in the scene, which I thought was interesting. But all that is totally outside of our class, but interesting things to find out. So they used to claim it, what they had. So on your sheet that I just gave you, it says scenario 1, scenario 2, scenario 3. Scenario 1 is, I think, the last publicized claim of the distribution of M&Ms at that point in time. And they said that it was 13% brown, 13% red, 14% yellow, 16% green, 20% orange, and 24% blue. But then I was looking again earlier because I always try to see if they've updated anything. And somebody had gotten in contact with the company, and apparently there are 2 separate places where they make M&Ms, Hackettstown, New Jersey, and Cleveland, Ohio. But the other interesting part is the 2 places where they make regular milk chocolate M&Ms do not use the same proportion of colors at their factory, which I don't understand why, but that's interesting. So if you have a bag, and this is why I was looking at them, on the back, on the left, I think it's the top left, there's like a serial code. And it's like it looks like it's printed on there. And towards the end, I think everybody said CLV in there somewhere, as opposed to HKP, which means they are from the Cleveland factory and not from the Hackettstown, New Jersey factory. So we always used to use scenario 1, which is the 13, 13, 14, 16, 20, and 24. But I think I want to try and do it versus the Cleveland, Ohio one, because it looks like that's where all y'all are from, and that sounds like the most up-to-date information we have. But I'm going to end up recording everybody's overall and see if we match better to one of the distributions than the other. Just kind of to see, which I'll show once I have everybody's. So what we are going to do is this going to be a goodness of fit, an independent, or a homogeneity one? Why is it definitely, obviously, goodness of fit? Because there's only one. So it's like, what is our category, or what is our variable color? And then we have different breakdowns of each color. So you are going to do this versus to see if your bag correctly matches what they have claimed the percentages for Cleveland, Ohio are. Now, if you do not have one, and that is fine, especially because I didn't say anything until after this class, I think most of you have at least somebody at your table. Don't split it, but just use somebody else's numbers. So like if you don't have a bag, but you have somebody at your table who has one, just ask them what their numbers are after they count them so that you can use theirs. Don't like mix between people because that's not random. So like just whatever you write down, make it be from a single bag. Does that make sense? For the most part, I'm pretty much just going to say, okay, go. It's up to you from the rest of the class period. Obviously, I'll walk around and help. So you're writing your information out. So you'll write out what your observed is. You have to calculate to find your expected. That third column is find the chi-square value for that color. So the sum of the very last one will end up being the overall chi-squared. And then don't overlook what I wrote underneath it where it says which color contributed most to your chi-square statistic and how do you know this? So like that's part of what I'm counting as your quiz grade is like the stuff up top. Well, I'll get a second here. Questions for me before you get started, like right now? All right, so I'm going to turn off the video and then I can answer questions and all that stuff. Oh, the other thing is, so I have posted 2 reviews for tomorrow. One is multiple choice and one is free response. This should not take you a full class period. So when you finish, I would just go ahead and start working on the multiple choice that I posted. Looking at it online is fine because it's printed kind of weird anyway. But I would go ahead and start working on tomorrow before the end of the day. Other than that, I'll come around individually and answer questions.